Hi, welcome to the Chico Math Lab. And now is the time to work on some differential equation problem again. So for today, the problem we're going to work on is this differential equation is 1 plus ex y prime equal to ex. All right, let's take a look how we're going to approach this problem. And first things when I look at this problem, I observed, for example, the x and the y. So like this is ex and this is 1 plus ex. They are kind of by themselves, so that's good. And then also for this y here, it's also kind of by itself, right? So then I know even this is y 1 plus ex y prime e to ex is not a linear form. But then because you see the functions kind of like separate, like like the x has all the x together, y has y. So this gives me an idea. So this could be a very good candidate by using the variable separation. Right, separate the variables. And I like to separate the variables because it makes the differential equation a lot easier. Okay, so let's take a look. How do we do this? All right, because remember the highlight I have here. So the first is here, like always, I like to separate that one, the y prime. I always like to put a dy, dx. So this is easier for me to visualize it. Okay, so now because I notice the ex and the y, they are the function by itself, so I can see is variable separation will work or not. So I put all the x on one side. So my left-hand side will just have y left and the dy's, right? Then I move the dx over, and so this is my dx. Then itself here, this is ex, then 1 plus ex. Wow, very good, right? Because so I know I'd be able to separate it to the, variable separation. See here, this is all x by x function by itself. So that's great. Okay, so so make the problem a lot easier. So what I need to do now? Now I will just do the integrator both sides here, right? So I integrate both sides, just like we always, we always did after you separate, let's make it easier. So you integrate both sides here. Okay, so integrate both sides. Okay, so the left-hand side, this one is easy. It's just y squared over 2, right? Use the power rule. So now let me highlight this one here. So later we will remember this is my left-hand side. Okay, so for my right-hand side here, this is the integration ex 1 plus ex dx. This integration is not too hard neither because if I use the u sub, so I would say u is equal to the 1 plus ex. Then the du dx is going to be equal to the ex dx. Wow, perfectly match here, right? Great. So this one's here, I can change that to the du over u, right? Du over u. So when the du over u is here, when I integrate that, what is going to be is the natural log u plus, oops, what happened here? Okay. So this will be the natural log u plus c here. All right, so now the u is 1 plus ex, substitute back. So now this one's here, I will have this is equal to natural log 1 plus ex plus c. Okay, and then I will have the y squared. I just simplified it a little bit. So y squared is equal to the 2 natural log 1 plus ex. 2c I can just say is another constant c. And now my initial condition is y0, 2. Okay, so initial condition is y0 equal to 2. So this one give me y equal to 2. So this is 4 is equal to the 2 ln. X equal to 0 is ln 2 plus c here. All right. So if you want to see here, this is a natural log 2 to the 2 plus c, so it's a natural log of 4 plus c. So I have my constants. C is equal to what? 4 minus natural log of 4. Now finally I can get my equations here. So my y squared is equal to, right? So the natural log 1 plus ex to the square plus 4 minus ln 4. Okay, so then I can find my y is equal to the plus minus, right? So plus minus the natural log 1 plus ex to the square plus 4 minus natural log of 4. So as you can see, if we do by the separation variable, it's become very easy. So that's what one trick here. You kind of remember, right? If you see the function, they're all by itself, and then that would be a good candidate for the variable separation when you do the um, differential equations here. All right, that's it. So hope this problem is pretty easy and hope to help you start some of your homework. All right, so have a nice day, and I will talk to you another time. Okay, bye.